they don't give us strong enough. Good. Hello, this is the quiz preview for the no calculator portion of tomorrow's quiz. The only one here that is in the parent function shifted form is the first one, which is in the form y equals a over x minus h plus k, where h is the vertical asymptote and k is the horizontal. So x equals -6 is your vertical asymptote, and x equals -2 is your horizontal asymptote. Number 2, the rules for that's the kind where you got to know if it's top heavy, bottom heavy, etc. For that one, the numerator and denominator have the same weight. Okay, what makes the denominator 0 though is -8, so that's going to be your vertical asymptote. Your horizontal asymptote, you see it's got x to the first on the top, x to the first on the bottom. So you look at the coefficients and you say 2 over 1 would equal y equals 2 for a horizontal asymptote. Third one, you have a 0 in the denominator. 5 would make the denominator 0, so it's the vertical asymptote, x equals 5. And then it's again equal weight, degree 1 in the top, degree 1 in the bottom. So 1 over 1. Y equals 1 would be your horizontal asymptote. For the next ones, we need to do more. We're going to name the x-intercepts. Do you remember how to find the x-intercepts? Okay, zeros of the numerator, right? The top, factor the top if it's factorable, or find the zeros of numerator. All right, so I'm going to factor the top, and that's going to be 2x minus 3 times 2x plus 3, or vice versa. And then if you set those to 0, you get 3 halves and -3 halves. So 3 halves, 0 is one of the x-intercepts. The other is -3 halves, 0. I'm not going to be picky about what order you write them. The vertical asymptote, we need to, bless you, we need to look at the denominator factored. So that'd be 2 times x squared minus 25. And then you would have to factor that difference of squares, x plus 5 times x minus 5. You've got 2 asymptotes for the vertical asymptotes, which are the zeros of the denominator. So VA, find the zeros of denominator. So we factor the denominator, set the factors to 0. Okay, zeros of the denominator would be 5 and -5. So you've got x equals -5 and x equals 5 as your vertical asymptotes. And that right away gets you the domain. Yes? No. The 2 does not have a variable. So it's not, you ignore it. I'm going to use that 2 for something else, but if it had an x, if it was 2x that you factored out, then 0 would also be a vertical asymptote. Okay, a factor out of x will be a x equals 0. Okay, good question. All right, so then our horizontal asymptotes, we need to look at the weight of the numerator and the denominator. They're both second degree, so they're equal weight. Numerator and denominator have equal weight. Okay, so you got degree 2, degree 2. Again, I hope you're understanding what I'm talking about. All right, now you take leading coefficient over leading coefficient over lead coefficient. I don't know, I'm writing that down in case somebody wants to write it down. So that's going to be 4 over 2. So our horizontal asymptote, 4 divided by 2, is y equals 2. To find a y-intercept, you put in 0 for x. So you need to substitute in 0 for x. I go for the original equation. I'm going to clean that up a little bit for a second so I can look at it a little better. If I put a 0 in for my x's, I'm going to have nothing right there. I'll have -9 over -50, which will give me 9/50ths. And then the domain is all reals except x cannot, I'm going to leave and not write the word except. X can't equal -5 or +5. Yes? You can. I'm not going to get real picky about it. I'm trying to make it a little bit simplified, a little less to write. You'd be okay. For the range, I forgot there was a range there. I don't know why it's not on my page, but anyway, There is a range blank, isn't there? Okay, so what would the range be? All right, so all reals and that big, if you write just an R, that's not correct. This is actually a symbol that stands for all real numbers. Okay, that symbol, it's not just an R, guys. So make sure you're writing it the way I'm writing it if you're going to use it. Otherwise, write the words all reals and then X can't except X can't equal. It really should be writing except, but anyway. X can't equal, or Y can't equal this time. If I can get my pen to go. Except Y can't equal 2. That's showing me you know it's Y values. All right, so what do I do for the x-intercept? I factor the numerators. That's going to be x minus 10 times, my pens didn't like me being that close to the edge, x minus 2. Okay, so my zeros are 10, 0, and 2, 0. The vertical asymptote, now I look at the denominator. I say x plus 3 can't equal 0, so that's going to be negative 3. X equals negative 3 is my vertical asymptote. To find my horizontal asymptote, I look at the weight of the numerator and the denominator. This one's top heavy. So what I told you was, since this, I probably won't even have one like that on where you have to answer the question because we did not do the oblique asymptotes. This one would have had an oblique asymptote, which would be a line. This is top heavy. So it would be no horizontal asymptote. So you just write none or NA. The y-intercept is going to be plugging in 0 for x. So if I do that, I'm going to get 20 over 3. Just write 20 over 3. The domain will be all reals except, I guess I'm going to start writing that again, x can't equal negative 3. And then I would not ask you the range on this. Okay, so you can just scratch the range if there was a blank there for range. All right, in number 6, I got to factor my denominator to x plus 3 times x minus 3. My x-intercept is the 0 of the numerator, so what I'm looking at when I do that is what makes x plus 4 equal to 0. That would be negative 4. Okay. To do the vertical asymptotes, you're looking at what does x plus 3 equal 0 and x minus 3 equals 0 give you. It would be x equals negative 3 and x equals 3. To find the vertical asymptote, horizontal asymptote, I check the weight of the numerator denominator. This one has a higher degree in the denominator, so it's called bottom heavy, we said, which means it has a horizontal asymptote where 0. Y equals 0. You don't do leading coefficient over leading coefficient unless they have equal power. Okay, those aren't equal in power. Their degree is different. Y-intercept, substituting 0 for x. If I put 0 for x, I'm going to get 4 over negative 9. So it's just negative 4/9. Your negative sign shouldn't really be in the denominator. Domain, all reals, except x can't equal 3 and negative 3. Can't be negative 3 or 3. And the range is all reals except y can't equal 0. All good with these? Okay, next I told you that you could cross off as I accidentally ran off the old before we took out obliques. So this is how you solve for an oblique asymptote. You actually do long division. You remember that? This would have been x minus 2 divided into that numerator, and then you find out it's a line x plus 8. Anyway, I'm not making you know that. If anybody wants me to teach it to them at some point, I can, but you'll learn it in pre-calculus. It's not that hard. It's not that bad. Okay. All right. What's the whole for this one? Well, you have to factor. So if you factored this, it'd be 5x over, factor out an x on the denominator. Oh, my pen's stuck. Excuse me a second. That'd be x times x minus 4. Now, this is what would have, this would have a 0 or a vertical asymptote at 0 if this were its denominator and we weren't about to cancel out the x's. So this would be x, that is the one that's a common factor, so x equals 0 would be where the hole is. Now, that's when I see x equals 0, I always think of a vertical line, so I don't want it written that way. So what I want is that you're going to tell me where the location is of that hole. How could you figure it out? Plug in 0 where? You can't plug it into the original. You got to plug it into the reduced equation. Okay, so that's 5 over x minus 4. So if you put 0 in there, you're going to get 5 over negative 4, or negative 5/4. Okay, so for the next one, we're going to factor this as x plus 5 times x minus 5 on the numerator, and the denominator factor out a 3. 3 times x plus 5. So in this case, the matching part is the x plus 5, which tells me I have an x value. At the x value of negative 5, I will have a hole. Okay, what's that going to be? Where's it going to be? If you plug in negative 5 into the original, okay, oh, sorry, the one that I reduced form, my pen's doing weird things. This would simplify to x minus 5 over 3. You plug in negative 5, you're going to get negative 5 minus 5 over 3, which is negative 10/3. Okay? And then you don't have this one, so let's talk about it. And I got to be honest with you, if there's a mistake in here, a typo, you will have a question like this on your quiz. You're going to have a couple where you've got to pick what equation matches the graph. So how would we approach this? You're going to try to look at every equation, or you're going to try to look at the graph? I'd look at the graph, okay? So I see the asymptotes are drawn for you on this particular one. This one would be x equals 2, and that's your vertical asymptote. And then this one is at y equals 2. There's a typo here because none of these equations gives you the right answer. None of them are right. Now I'll explain why. So let's just think about it, because if you can think about what I'm about to explain to you, why there's no equation here that fits this, then you will understand. You could probably write one for this. Okay, so let's try to write one. If you have a VA at 2, vertical asymptote at 2, your denominator could be something like x minus 2. Remember how it has to be the opposite of the sign of that? Okay, and that looks like to me, it could be A, B, or C. So I already know it's not D. So then I'm going to figure out what's wrong with it. If it has a horizontal asymptote at y equals 2, then it needed to have equal weight top and bottom. None of those have that. That's why I said if I added an x here, then that one would work. You with me? A wouldn't work because that'd be a y equals 1. So I could fix it if I put a 2 right there. So that fixes where we got. Now we have 2 equations. They're actually both the same that are correct. So one of these this one had to either have a 2 on it to get that horizontal asymptote, or this one needed an x on it so it would have equal weight top and bottom. So if you understand what I just went over there, you should be able to pick out the right equation. And they're going to be simple. They're not going to be crazy to identify. So are we good? All right. That is on the quiz. So now we're going to go to the other part of the, which is quiz preview. It says number 5. So technically, the no calc quiz is quiz 4, and then other parts quiz 5. Not that we need numbers on our quizzes. How do you find the x-intercepts? And I'm not doing a homework check tomorrow because I'm not going to be here for you guys. So I'm not going to do it to the other class when you won't have to do it, right? So I'll do it on Monday or Tuesday next week. Okay. How do you find the zeros? The x-intercept, sorry. Find the zeros of, all right. Find zeros of what? Of numerator or p of x. Okay. Or if you wrote the numerator, that's fine. How do you find the horizontal asymptotes? So you got quite a bit to say about this one, don't you? You must check the check degree of p of x and q of x. Now, you're going to have to go further with that. So if you check the degree of p of x and q of x, then if we want to start with bottom heavy, or it doesn't really matter what order. Okay, so if it's top heavy, then it would be none. No HA. If it's bottom heavy, y equals 0. HA is y equals 0. And if it's equal weight, okay, lead coefficient, y equals leading coefficient. Oops, let me write that carefully. I don't know what I was just, that came out too. Didn't mean to write that. My pen was going crazy. Y equals leading coefficient. Oh, it's just sticking on me. Okay, lead coefficient over leading coefficient. All right. And then third question is, how do you find the vertical asymptotes? You find zeros of the denominator, right? And or q of x. All right, and they would be x equals blah, blah, blah. So, all right, graph number 4. This one is in the, I'm thinking it's going to do this, because I'm anticipating ahead of time because of the negative sign. It won't probably be here and here. So that gives you kind of a good idea of what you're doing, if you're doing it correctly or not. I've got a horizontal asymptote at y equals 3. So I'm going to go ahead and put that in my picture. I have a vertical asymptote of x equals -2. Okay, then I'm going to graph it, or I can write my domain would be all reals except x can't equal -2, and for the range, all reals except y can't equal -2. I mean 3. Y can't equal 3. All right, I'm going to make a little t-chart. I think that we should always get our y-intercept if it's possible, so I can put in 0 for x. If I put in 0, I would get -5 halves, which is -2.5 plus 3, so that'd be 0.5. Then 0.51 point on the graph. I'm going to put in a number to the left and a number to the right of the vertical asymptote. An x value to the left would be -3, and to the right would be -1. So those are the other 2 points I'm going to do. So I'll put in -3 in here. That would give me a denominator of -1. And that would be -5 over -1, which would be +5. 5 plus 3 is 8. And you guys, by now, you're on the calculator part. You could go in the table if you wanted. Okay, plug in -1. You get 1 in the denominator. So I'd have -5 plus 3, which would be -2. So -3, 8. Oh, that's kind of off the graph. Because it stopped at 7. Oh, well, maybe I better put in -4 also. So I want something that looks a little better. -5, -4 would be -2. -5 divided by -2 would be +2.5. That'd be 5.5. Did I do that right? Okay. -4, 5.5. So this thing's kind of out here. It will run along its asymptote. This one's just a little pretty far away because of that 5 in the numerator. And then it stretches away from the intersection of the asymptotes. So I'll plot the -1, -2, and then sketch this section. So that's what that one looks like. Now, the next one is not in the transformation form. We've got to think about all those little rules. I'm going to go ahead and say my x-intercept is going to be -3, 0. I already got a point. Okay, -3, 0. My horizontal asymptote, I've got equal weight top and bottom. So that means I'm going to do leading coefficient over leading coefficient. So that's going to give me y equals 1/2. And then the denominator gives me the vertical asymptote. So I have to set that to 0. That's going to be -5/2, which would be -2.5. You can write it as a decimal. -2.5. Oh my gosh. I'm going to put these asymptotes in. So I'm going to tell you, this is a kind that there's no way you're getting off a graphing calculator. You're going to see those. You're going to have to know what you're doing. Because it's not going to show you hardly anything. It'll look like little stubs. All right, because this is so close and tight to its asymptotes. Oh my. Let's see. What other points should I put in? Maybe I already got -3, 0, so I know what's going on here. It's going like this. Okay. And so I'm going to stick in -2 now because it's really close to its asymptote, -2.5. -2 will give me a 1 in the numerator. And then on the denominator, I'll have that'd be -4 plus 5, so that's 1. So it's 1/1, which is -2, 1. That's about all I can get here. And then that's going to be running along its asymptotes as well. All right, so the domain's all reals except x can't equal -2.5. And the range is all reals except y can't equal 1/2. Okay. Anybody still need 5? All right, and hoping that you've got these all right so far because you were supposed to have tried them beforehand, but I want to make sure I'm explaining them all. All right, the 6th one. Any x-intercepts? Can you make that numerator 0? No, so there aren't any. The vertical asymptotes, x equals -1 and x equals 4. This thing is bottom heavy, so that's when you have y equals 0 for your horizontal asymptote. Maybe you want to write that one's bottom heavy. Okay, that's that rule. And you actually have a little cheat sheet then. The domain, all reals except x can't equal -1 or 4. Okay, I'm going to get these asymptotes in there. Oh, I will get the y-intercept quick in a minute. My pen is spasming. Okay, the y-intercept, putting in 0 for x, it would give me 2/1 times -4. So that's 2/4, which is -1/2. Okay, I've got 3 sections that I need to find points in. I'm doing these by hand as if you don't have a calculator. Okay, so I'm going to stick in -2 because it's to the left of the leftmost vertical asymptote. If I plug in -2, I'm going to have 2 on top. I'll have -1 times, okay, let's see. If I put in -2 there, I'll get -1 in the first parentheses. Pardon? -2 is why I'm plugging in -2. And then I would have 2 over -2 plus, this is what I'm doing. Okay, I'll do it over here. And that would be -2 minus 4. All right, I'll just write the answer here. I'll get rid of that. That's going to give me 2 on the top, and that will be -1 times -6, so it's 2/6, which is 1/3. Okay, so -2 1/3 means I can tell that it's above, something like that. So, oh, I forgot to put in my horizontal asymptote. That would be helpful to remind myself that that is there. So then this is running along that, comes and hits at -2 1/3, and then shoots straight up the other asymptote, the vertical asymptote. Okay, now I'm looking in the middle section. I already have 1 point, which was my y-intercept. I think I'm going to go ahead and put in 3 so I can see what's going on over closer to the other asymptote. So I'll plug in +3, which will give me 2 on top, of course. And then 3 plus 1 would be 4. 3 minus 4 would be -1. So I've got 2 over -4, which is -1/2. So 3 -1/2. Notice that that mirrors with that point over here, that y-intercept. So that means what's going on in here is it's running along the asymptote, comes up, and then loops back down. And then to the right of the 4 vertical asymptote, I'm going to plug in 5. I'll have 2 on top. If I plug in 5 in the denominator, I'll have 6 times 1, which is 1/3. 2/6 is 1/3. So 5 1/3. This thing had all kinds of symmetry. All right, and now I've got it graphed. Okay, next. On the other side, it says, for each graph below, sketch any vertical and horizontal asymptotes and give their equations. Did anybody need me to go back? I mean to be too fast. Okay. This one has, you can tell by the denominator, it has a vertical asymptote at x equals 0. And then I'm just going to draw it in on the picture. And then I can tell the horizontal asymptote because I look at the weight of the numerator and denominator. They're equal weight, so I do 4 over 2, which is y equals 2. And that's where it is on the picture. Number 8, we never graphed anything like that. Doesn't mean we can't tell what the asymptote would be. This one is bottom heavy, so that's why it has a horizontal asymptote at y equals 0. Does it have a vertical asymptote? Can you factor the denominator even? Okay, so there is no vertical asymptote. Okay, third one, or number 9. Factor that denominator x minus 2 times x plus 2. The numerator will never be 0 because you can't square something and get a negative. So that doesn't have any x-intercepts. That's all that meant. But I see that I have a vertical asymptote at x equals 2 and one at x equals -2. Drawing them in. And then what's the horizontal? Is y equals equal weight top and bottom, so 1. All right. So next one, you guys, this is when I made you change number 10. Did everybody get that changed yesterday? Nathan, you weren't here, so like this side we asked that we put x plus 1 on the denominator instead of just x. Got it? And then we eliminated one of the questions as well. So we're going to state the x-intercepts. X minus 1 times x plus 1 would be the factored numerator, which gives me an x-intercept at 1, 0 and negative 1, 0. Oh, I screwed up. What did I do wrong? I didn't look at the bottom just now. Are these both x-intercepts? One of them is, one of them's not. Yep, we have a common factor to the numerator and the denominator. So we've got a whole. Let's look at the reduced form of this thing. It's y equals x minus 1. So which did I eliminate? I eliminated this one, the negative 1 x-intercept. So that's not an intercept. Just 1, 0 is. We can write that one on our graph. Okay. Part B says write the equations of all vertical asymptotes. Do we have any? No. There are no verticals. C, write the equation of any horizontal asymptotes. We don't have any. D says state the y-intercept. Well, let's put in 0 for x. It's going to have a y-intercept. It's going to be at negative 1. And E says state the x-coordinate of any holes. I'm going to ask for the whole point. So it's at negative 1 something. So what if we had to graph this thing? Negative 1, y equals negative 1 minus 1 would give me negative 2. So at negative 1, negative 2, we put an open circle. Now, that line was a y equals x minus 1. It is linear. It has a y-intercept of negative 1 and a slope of 1. So I can just make some more points. Up 1, right 1. Down 1, left 1. And graph the line. Okay, so next, grab in each rational function, state the x-intercepts. That's going to be 0, 0. How do I know that? Because the numerator has an x in it. So that's set to 0, 0, 0 would be the answer. B, write the equation of all verticals, x equals 2. That's what makes the denominator 0. Part C, the equation of any horizontal asymptotes. This is equal weight, top and bottom, so it's going to be y equals 1 over 1, y equals 1. Come on, pen. Okay, D is state the y-intercept, plug in 0 for x, you've got 0, 0. It's the same as the x-intercept. In E, do we have any holes? No. F, we got to graph it. Okay, so I'm going to put in 1 over negative 1 was what I would get, which is, whatever, 1, negative 1. I'm going to go ahead and sketch it. Oh, I got my y-intercept to run into, bing, and then run down. Make sure you put arrows on. I shouldn't have crossed that, but I drew my asymptote in there. I was a little sloppy. What else should I plug in? Yep, 3. Okay. That gives me 3 on top, and on the bottom 3 minus 2, which is 1, so 3, 3 is a point on the graph. Maybe I'll go ahead and plug in 4 also. That'll give me 4 on top and 2 on the bottom, so 4, 2. And then I could sketch that. Oops. Try to hit your points. And there is one more question of the day. Oh, no, it's not. We crossed out this one. No. Am I supposed to do this one? Okay, that's the one we need to do. All right. It's just your number 13. That's what it was. Okay. All right, what's number 1? A was x-intercepts, right? All right, there aren't any. B was equations of vertical asymptotes, x equals 2. Put it on my graph. Horizontal asymptotes, this is bottom heavy, so y equals 0. Larger degree in the denominator than the numerator. D was at y-intercept, plug in 0 for x. That would be 2 over negative 2, so 0, negative 1. I already know what this is going to do here. And maybe we should plug in 1 into our table for x. If I did, I would have 2 over 1 minus 2, which would be 2 over negative 1, and that's negative 2. 1, negative 2 certainly looks like I hit it. Okay. Finish my arrows. And then I'm going to go to the right side of the vertical asymptote and stick in a 3 into my equation. It's going to give me 2 over 3 minus 2, which is 2 over 1. So I got 3, 2 for a point. And maybe we'll put in 4. 2 over 4 minus 2 would be 2 over 2, which is 1. Sketch. And then we have one more question. Oh, what was E? Holes? There's no holes. When does the graph of a rational function have a hole? That is not technically correct, but it's close. I know what you're saying. All right, that would be, so I'm going to tell you that I even wrote it technically incorrect earlier because I said when there is a common factor with an x in it, though. It can't just be a common factor of a number, right? With x in it in numerator and denominator. Pardon me? No. Point discontinuity is, you're not telling me how you know if it's going to have a point discontinuity. A point discontinuity is a hole. So they're like one and the same thing. You have to say something. You have to have the common factor with x in it in both the numerator and denominator.